Okay, in this video, we're going to talk about the properties of logarithms. I would go ahead and copy this box here if I were you, just so you can have the information. Pretty much we are going to be using properties similar to that of the exponentials and apply them to logs. So there's three main ones. Okay, we have the product rule, which tells us that if we're multiplying terms within a logarithm, we can actually expand that to where you have more than one log and we add the terms. So here in this case right here for a, you have a times c, which is two terms. So therefore you have two logarithms and one for each one, and you're going to combine them with an addition sign, so adding. Okay, and this would be your expanded form. So expanded form is everything on the right. The second one, letter B, is our quotient rule. So this one tells us that if we're dividing, and this may or may not be in parentheses, okay? If we're dividing terms, we can expand that by subtraction. And again, this goes back to our exponent rules where when you're dividing exponents with the same base, you actually subtract the powers, okay? So same concept here, because remember that logs and exponents are related. Okay? And the final one is the power rule. And this one tells us that if we have a term with a power, we can expand this by moving the power, so this would be our power n, to the front of the log and multiply. Okay, so again, this is our expanded form. And we use these properties to solve usually, okay? So let's go ahead and look at some examples. I'm just going to example after example. Again, make sure you copy this into your notes before you do the examples. Okay, so let's start with example 1, something really basic, and I will be referring to the properties in the box above. So let's say you have log base 2 of x times y, and we are asking for you to expand this, okay? So expanded form means you're going to have more than one log, and you're going to try to get this to look like a longer expression, okay? So if we refer back to our box up here, you can see right away that this is going to be the product rule, the first one, and we're going to go ahead and use addition to expand that. So this times right here is going to kind of turn into a plus sign. Okay, so first we want to go ahead and make sure that we have enough logs. We have x and y, which is two terms. So I'm going to have two logs, and the base just stays the same for both. Okay, and the first term is x, so let's put an x here. Second term is y. Let's put a y here. And the property says that if we're going to expand this, we're going to combine this with a plus. So it looks like that. That's it. That would be our expanded form. Okay, so this is expanded form. Okay, which makes this one, of course, the condensed form. We're going to be going back and forth. Okay, let's look at another example. So using the next property, and then we'll combine some of these at the end. Using the next property, let's say we have log base 5 of 24 over w. I'm just kind of making the letters up. Well, we're going to go ahead and use the quotient rule. So the quotient rule tells us that if we're dividing terms, we actually subtract them when we go into the expanded form. Okay, so again, we have two terms. So let's go ahead and do two logs with the same base, base 5. And then we're going to put each term. So the first one is 24. And I'll go ahead and put this one in parentheses, why not? Just so you know, the parentheses are not absolutely necessary for these. Usually you want to put them when you have more than one term, but it doesn't hurt either way. Okay. The second one is a w, and this division is now going to be a minus. That's it. That is our expanded form. Okay, so you might ask, well, these look kind of similar to the chart above, so that's why they're so easy. So let's go ahead and look at one that has a little bit more terms. Let's say log base 6, and we'll do 3xy over I don't know, z. Okay, so this is going to be a combination problem. We're trying to expand this one. Okay, so the first thing you want to do is look at, see how many terms we have. So we have a 3. Let me use a different color. So we have a 3, we have x, y, and z, a total of 4 terms. So we're going to have 4 logs. So log base 6, log base 6, log base of 6, and log base of 6. And next to each term, we're going to go ahead and put 1 of the letters. Order does matter, so we need to go in order. So the first one is a 3. Let me use a different color. So the first one is a 3. Okay, that's this one. Then we have x. Then we have y. And then we have z. Okay, so order is important because we do have a division, which means there's going to be a subtraction between 2 of these at least. The first 3x, y are all being multiplied, so that means this one's just going to be a plus. So plus, plus. But when we go from y to z, that's our division. So that property would be subtraction. So on this last one, just make sure that you have your subtraction symbol. Okay, make that a little bit nicer. Okay, and that's it. That would be the expanded form of this particular problem. Okay, let's go ahead and do one that looks a little more complicated, just in case you see something like this. So let's say we have log base of 8, and we have x plus 1 times x minus 4. Why not throw some binomials in there? X minus 2. So we have this humongous expression, okay? Well, the same rules apply, but when there's parentheses around terms like this, you want to consider each parentheses as a term. So this is one term, this is another, and this one is another. Don't let the pluses and minuses in between these confuse you. Remember that the property goes from condensed to expanded form. You're looking for multiplication and division. If you have plus and minuses, those are going to stay there, okay? So we have a total of 3 terms. We have one right here. So log base 8 of x plus 1, that's one term. Let's use this color. We have another term here. And because these 2 terms are being multiplied, so this means multiplication, the parentheses, we're going to put an addition sign. So plus log base of 8, again, same base, all this, x minus 4. And then we have the last one underneath, so we have a division, which goes to this one. So minus log base of 8, x minus 2. Okay, now on these, you do want to make sure you have parentheses because, again, that x plus 1 is one term. This is all together. If you weren't to put a parentheses here, then you might not be sure where that 1 belongs to, okay? But anyway, so that's it. You have your expanded form right here. Okay, so far we've touched upon the first 2 properties, which would be A and B, so these 2 here. Okay, now we're going to look at the final one and see how they all come together. Say we have log base of 4 of x to the 10th power. It's a 10. This property is the last one, the power rule. So what we're going to be doing here is pretty much the exponent, so in this case 10, gets moved to the front and it becomes a coefficient. In other words, like a big number. So this would be 10 log base 4, and then the x just stays there of x. That's it. The reason we do this is because if we're trying to solve a particular equation, dividing by 10, which would be the 10 right here, is much easier to work with than this over here. Okay, so this would be your expanded form, and this would be the condensed. These ones they're a little bit trickier to see because they kind of look the same length, but remember that your expanded will have the numbers in the front, okay, for these rules. Let's try another example. Example number 6. And let's do a combination problem. So let's do log base 7 of x squared over 3y. And I'm just kind of making these up, so you can apply to a number of problems. All right, so here we have three terms. We have x squared, we have 3, and we have y. So we're going to have 3 logs. So log base 7, log base 7, log base 7. Okay. Our first one is that x squared, so we're going to have the x here. But remember that the little 2 is a power. This is the one that gets moved to the front. So we're going to put that 2 here in the front. Okay. The 3 underneath is on the bottom, separated by this line, so we have to put a minus right here. Okay, and then we're going to take care of that 3, this 3 right here. So that would be here by this log. And finally, we have y, which is also underneath. But since we already took care of the division here on this spot right here, we're just going to consider 3 times y, which would be multiplication. So that would be a plus. And then there's my y. And that's it. That's your expanded form. Okay, a couple more examples, and that'll be it for this one. Let's say we have something weird looking like, let's say, base 5, square root of x. Okay. This one is actually just the third property, but I did want to show it because people tend to forget an important property of the square root, or I should say equivalency. This has an intermediate step. So this is the same as, somewhere right here, this is the same as log base 5 x to the power of 1 over 2. For those of you who forgot, this square root is the same as a power of 1/2. Okay, so that makes our life a little bit easier because now that we know what the power is, we can expand it. Okay, so from here we're going to take that 1/2, put it in the front, put our log base 5 of x. That's it. Just to kind of piggyback off of this one, the same rule applies for other roots. So let's say you have log base 5 of a cube root. Okay, well, the cube root is just the same as the 1 over 3. So this would be 1 over 3 log base 5 of x in the expanded form. Okay, let's go ahead and do one more. And this time I'm going to go ahead and do one that's backwards. I'm only going to do one because once you've done going one way, the other way is not too bad. Okay, so let's say we have, now we're going from from expanded to condensed. So this is going to be the expanded form to condensed. So expanded form would look something like this. 2 log base 4 of x minus 3 log base 4 of y. It's important to note that the bases have to be the same. If these are not the same, then we cannot condense it. So they have to be the same. Okay, so we're going to go ahead and, these are the same, we're going to go ahead and try to condense this. When you're condensing, you only have one logarithm because we're going from the long version to the short version. The first thing I have here is that x, so my x goes first. There is a 2 in the front, but remember that we're going backwards, so the 2 is going to jump back over here to the exponent. So x squared. Okay. Next we have a minus. So minus means divide, so we're going to put our division line. I'm going to do a different color for that. So there's my division line. And you see that we have a 3 and a y. But again, remember that this 3 is actually a power. It jumps over here to the y. So this would be y cubed. And this would be fine just how it is. I'm going to go ahead and put parentheses just for the sake of neatness. But that is it. That is our condensed form. Okay. So these are not that bad. I can go ahead and do one final one. I know I said that was the last one, but let's just do one more just because we have time. Let's say we have 1 over 2 log base of 2 x minus 1. We're going to make it a complicated one, plus 2 log base 2 of w. Okay. So again, this is expanded. We're going to go from expanded to condensed. So let's rewrite this. But we have the same bases, base 2. So we're good to go on that part. So we have log base 2. The first term is this right here, x minus 1. Okay, it's in parentheses, so I can put it in parentheses, but I'm going to kind of look ahead and see that there is a 1/2 here. So I know that the 1/2 is going to jump here to the exponent. So it would look something like this, x to minus 1 to the 1/2. But remember what I said previously, that this 1/2 is equal to a square root. So when you're condensing, you want it to look as simplified as possible. In this case, this would be your more accurate form. Okay, so we have all this log base 2 of square root of x minus 1. Then I have a plus, so times, because you're going backwards. And again, I have another power, so 2 and a w. It's going to jump here, so w squared. I'm going to go ahead and put my parentheses just so that it looks nice and neat. And that's it. This is my condensed form for this particular problem. Okay, that's it. That's how you do properties of logs. They can get more difficult, but really all you need is these 3 properties.